is the launch of our second technical grade product. The first, of course, was the RQ1. We were asked for a more economical version, and we wanted to position a technical grade product in an area that we think is not served very well. So we're using this opportunity to create the GQ4. The GQ4 is essentially the exact same performance as the RQ1, but in a more economical package and with a connector that's common to our GX series. So the main highlights of the device are it's a 5-degree per hour gyro bias stability, which is the same as our RQ1. Low accelerometer noise, a cost-effective alternative to the RQ1. It is significantly smaller and lighter than the RQ1, but it does share the same footprint, so it does mount on the exact same mounting holes and alignment pins. The weight is about 1/2 the weight of the RQ1, and you'll see as we look at the drawings later that it's slightly lower profile than the RQ1 also. One new feature that we're introducing and we'll start to migrate across our product line is a constellation GNSS receiver. With the Beidou satellite constellation coming online and GLONASS being available, we're now able to move to a multi-constellation receiver. It gives you much better performance, especially in urban canyons, and better accuracy. The temperature range is standard -40 to +85. And, of course, the interface is backward compatible using our MIP protocol. This is approximately where the GQ4 sits in the area of price and versus performance. It's a lower-end technical grade sensor, but it's a very economical one. I think I'd even put it a little lower on the chart in terms of price because it's lower than the RQ1. We really do try to focus on the most cost-effective and best cost versus performance ratio in the industry. This is a slide that shows you the dramatic difference in size between our GX series and the GQ and RQ series, with the also the performance difference. So the industrial grade, our GX series, is kind of on the high end of the industrial grade performance. It's very small. We focus on the small size, and the GQ4 is actually very small for its grade. It's 40% smaller in volume than the RQ1, yet the GX4 is significantly smaller even than the GQ4. So there's a trade-off there. We'd like to make the smallest sensors possible. This next slide gives you a comparison between the RQ1 and the GQ4. As you can see, the mounting holes are the same, but the outside dimensions are significantly smaller. It's lower, and it's half the weight. This is a short list of applications. Every time we try and come up with a list of applications, it gets to be too long, so we try to shorten it. These things are used, because of their size, they're used in such a variety of applications that we can't really pin one down. Though the most popular are platform stabilization, camera stabilization, and autopilots. The other thing about the packaging is, because they're small, we did not make the GQ4 or the GX series weatherproof or IP67 like some of our competitors. We find a lot of people use it actually as an OEM unit that's built into larger packaging. To cut the cost down a little bit, or actually significantly, we use a packaging that's still very rugged. The GQ4 packaging is CNC aluminum, anodized aluminum. So it's a rugged package. It's just not waterproof. So how it's different? This is the list that we think differentiates us from the competition. It's, of course, high performance, tactical grade, but it's more cost effective, it's smaller and lighter. It's backward compatible with our MIP protocol, which we think is a significant advantage. It shares the mounting of the RQ1. It's still rugged. The sensor board and the electronics we use in the GQ4 are shared with the RQ1. We just don't do things like conformal coating as we do on the RQ1, and are able to lower the cost in several other ways. But it still is the same rugged circuitry that we have in the RQ1. So it does survive high shock, high vibration, high temperature extremes. And of course, our dual processor architecture gives us a significant advantage because we can get the maximum performance from our Kalman filter with a dedicated processor. Just a slide here. We like to reiterate that the MIP protocol is an advantage. We designed it specifically for inertial products. It allows a lot of flexibility. We use it internally, and it's been a great advantage internally because we just simply use all our same test and calibration equipment without any changes, and we can very quickly move new product into the manufacturing process without having to worry about protocol. It's a similar benefit to customers, too. If they design for MicroStrain, they can be assured that their development costs are one-time. There are some minor differences as we add features, but we still try and maintain as much compatibility between devices as possible. Another list with a few of the more detailed features. It's a GNSS-aided inertial navigation system. We want to remind people that because it's not a free inertial system. It does require satellite lock. It does require satellite reception to work properly. Low noise triaxial 5G accelerometers. We use the best accelerometers that are available in the class that we're designed for. We do not have a 16G option with the RQ1 or the GQ4. We'd like to hear from you if you think that it's an option that we should pursue. We do offer the 4 rate ranges on the gyroscopes, 75, 150, 300, and 900, 300 being the standard product. It does have triaxial magnetometer on board, fully calibrated. Also includes a pressure altimeter, and it uses our standard microDB9 connector that's used on the GX series that we've used for 10, 11 years now. It's the dual communications, USB or RS-232 on the same connector. So we'll drop right in any application that's already been designed for one of our GX series. Concurrent tracking multi-constellation satellite radio receiver, 105 grams. It's a really nice little compact unit, and the CNC aluminum, of course, makes a really nice solid package. So that concludes our presentation.